All right, it's 2:01. If you guys can't hear me, can you maybe raise a hand just to let me know? Um, awesome, but otherwise, welcome to GoFigr OpenLab. My name is Maciej Pakula, and I am the founder of GoFigr. I'm really excited to be here and to be able to show you what GoFigr is and to our existing users to show off some of the new features that you might not be aware of. Um, so I promise I don't have too many slides. We're going to do some actual coding very soon, but just very briefly, if you haven't used GoFigr before, the core concept behind it is actually pretty simple. Um, what we do is we automatically capture your figures in R and Python as they're generated, and we add QR codes to them. Uh, and what that does is that it actually embeds the full provenance trail for each figure within that figure itself. So if you were to go to the GoFigure link here for the volcano plot, you would see the full data, the full code as it existed when that figure was generated, as well as the full revision history if you iterated on, say, parameters and so on. I think this kind of provenance tracking is important for really any industry, but I think it's specifically important for biotech just because if you've done any kind of computational biology or bioinformatics work, you know that figures are currency of scientific communication. Um, you're sharing figures with your stakeholders, with other people on your team, with biologists, with people in the lab. But it's important to not share just the image, right? You want to make sure that you embed the scientific context behind every figure. Um, so you might get questions like, does this figure include smokers? If you generated this 6 months ago, will you even remember? Which version of the data did we use? How did we average the replicates, if at all? And my personal favorite, can you redo with our corporate colors? I used to do computational biology as a career, both as an individual contributor and managing teams of data scientists. So this comes up all the time in fast-moving, high-performance biotech and like data heavy organizations. So with GoFigure, we take that unknown away. We automatically capture that whole chain of provenance for every figure that you generate in R and Python. So today, what I hope to do is to go through um, an actual TCGA data analysis with GoFigure set up and plugged in. Specifically, we're going to look at two TCGA projects. That's LUAD, that's lung adeno, and LUSC, lung squamous. And we're going to do some basic differential expression analysis in R. Um, if there is time, we're going to follow up with an analysis in Python. We fully support both environments, so even if we don't get to Python, everything that you see in R is available in Python as well. Two specific features that I'm really excited to show to you today, and these are pretty new and still in beta, but personally, I'm very excited. One is called Clean Room, and that's where we turn every static ggplot or seaborn figure that you would otherwise just save as an image, and we turn those into fully interactive assets in the browser that you can rerun, tweak, months down the road. And finally, we're going to go over our stories feature where you can take figures that you generated from your notebooks and turn them into, a soup to nuts AI generated slide deck that you can use as a draft for, an actual presentation you might want to give based on the data analysis. Um, Before we dive into any of the code, I just wanted to bring your guys' attention to some resources. First, the code and the slides from today are available on GitHub. So go ahead and check it out. Feel free to play around. Um, GoFigure has a free tier. You can just head on over to app.gofigure.io/register and register for an account. If you use it and decide you like it, like send me an email at maciej@gofigure.io and I'll give you a free upgrade. Finally, if you have any questions, we have our documentation portal at docs.gofigure.io. Or you can just reach out to me directly and I'll be happy to answer your questions or get you set up. So with that out of the way, maybe we can get out of PowerPoint and do some actual data analysis. What do you guys think? Awesome. Um, so before we do that, um, you would head on over to app.gofigure.io. You would register for a new account, or you can just sign in with your Google account. I already have an account, so I'm just gonna sign right in. Um, when you log in for the first time, you are going to get a blank workspace. The default workspace that everybody starts with is called Scratchpad. And think of a workspace as a repository for your analyses, your figures, your notebooks, your data sets, and so on. So everybody gets a Scratchpad just for personal experimentation. But for most teams, say you're working on a data science team, you would create a workspace for your team, your project, or your company. So let's do that. Create. So now I'm in my GoFigure webinar workspace. So I have the repository set up, and now I can actually go to R and start capturing some figures. The easiest way to get started is to actually use our quick actions here. So what we're interested in for today is real-time capture. So as the code is executing, capturing and versioning those figures. So I would open this wizard here. As I mentioned, we fully support both Python and R. In Python, we support notebooks as well as standalone Python scripts. And in R, we support like pretty much any flavor of R. So R Markdown, R scripts, R Studio, Quarto, and so on. So let's select R. Installation is very straightforward. You load DevTools, you install our library from GitHub. You load it and you call a tool called gfconfig to configure it, and I'll show you what that looks in a moment. We do have a library on CRAN, but that one tends to lag behind the GitHub version. So if you want the latest features, just use GitHub. So if you click next, assuming you already ran gfconfig, you can just accept those defaults. And this will actually give you an example analysis or a starter analysis that you can use for syncing figures. But let's go back and let's actually show you what this setup process looks like. So I'm going to use Positron, which is the new IDE from the makers of RStudio, but we do support RStudio as well. So you can choose your tools, and we fully support them. So let's restart so that we're starting fresh. And it wouldn't be a bioinformatics demo if we didn't get some past package warnings, but this was installed and this is available now, so now I can do. You only have to run gfconfig once to set up your username and your API key. So if we run this, this will actually open a web browser for you where you can authenticate. So confirm. And now we can go back to Positron. It's going to ask you for an API key because most likely this is the first time you're using the tool. You can just let it generate one for you. So we're going to leave it empty and press enter. I'm going to call it workshop. And it's going to ask you, like when you run analyses after you run gfconfig, like which workspace do you want your analyses to go into? We just created GoFigure webinar, so I'm just going to select that one. So yeah, this will tell me where the configuration was saved, but that's really all you need. Now you can jump back to R and Python and use the tool. For this differential expression analysis, this downloads data from TCGA for the two lung projects. So LUAD for lung adeno and LUSC for lung squamous. This will take about 30 minutes to download. If you're interested in seeing how to do this, like you're more than welcome to run this, but um, just to keep this simple, I actually provided a cached version here that you can download. Um, so let's use the cached version. So this is the markdown document I'm going to use for my differential expression analysis. Like this is a pretty box standard QMD document. You set up your knitter settings, you install or load the libraries that you're going to need in your analysis. Um, and then all you need to do to enable GoFigure in this notebook is this single call to GoFigure enable. Um, all arguments to this are optional. If you don't specify an analysis name, it's just going to use the name of your notebook. But just here to make it a little prettier, I'm going to specify that this is the TCGA lung cancer analysis. So now when you run this, it will tell you that GoFigure is active in this workspace, which is what we want. So now we can actually go ahead and load some data. Um, so here I'm going to use the RDS file generated by the other script or downloaded from our CDN. But I want to focus your attention on this one call to GoFigure here. As you know, in bioinformatics, a lot of data is fairly ad hoc, especially in discovery. So you might have a sample sheet or a manifest from an email from a collaborator. It's sitting in your downloads folder, so not very traceable. But GoFigure gives you the tools to make every single ad hoc file that serves as an input to your analysis 100% traceable. So here I'm calling GoFigure on my RDS path. And what that does is it actually creates what we call an asset in the portal. So now this RDS path is fully versioned, fully tracked, and will now become linked to every single figure that we generate in this notebook. So if you click on this, this is what it looks like, right? I'm in my GoFigure webinar workspace. This is the file, just one version because it hasn't changed. You can download it, use it later in other analyses if you want. But now, that ad hoc sample sheet becomes a fully tracked, provable asset in our system. So now going back to our analysis, we loaded the RDS file. We have the data. Let's actually do some analysis and generate some figures. In exploratory stuff like this, probably the first thing that you're going to run is something like PCA or UMAP. So that's exactly what we're doing here. We're calculating the principal components. We're putting them into a data frame. And then we're creating a ggplot to visualize them. The only call to GoFigure here that I'm doing is the pipe into publish. So this is a vanilla ggplot object that I'm just passing to publish, and that's what makes it traceable and captured by our system. So now when you run this, here's our PCA plot, and here's the link to the plot on GoFigure. If you now click on this link, there's the image, obviously, but I just want to show you all the other things that we automatically captured for you in the background. So one, we generate a description for you automatically. So if you share this with a collaborator, you get a nice AI-generated description of what this is showing. You can obviously edit this yourself, but most of the time AI does a good job. So you can share that directly. You can ask questions about the figure. For example, what are some potential issues that this might reflect? But also you get all this provenance thing on the bottom. If you want to get the exact code used to generate this figure, we capture the input file for you as it existed when the figure was generated. So this is now recorded and this can't change, right? We also capture the data. So here are my principal components as a data frame that I can download to CSV or Excel. We capture data files, so that's the RDS file that I mentioned that we use as an input. We capture session info. and a bunch of other metadata, like if you're using a Git repository for your notebook, we capture the last hash and the exact commit link um, to when that figure was generated. Um, so now let's go back to our analysis. Like a key value proposition for us is that we don't track just that one version. We track all the versions. So as you iterate with your stakeholders or just yourself and you tweak your analysis, all those versions get captured and tracked. So let's make a small change here. And I know this is technically now a bug because I'm saying this is PC2, but I'm actually grabbing PC3, but bear with me for a second. So this would have created a new revision. Like this link is unique to this specific version of the plot. So if you click on it, one second. If you click on it, you will get that new updated figure. And because the code was captured as it existed when that figure was created, now you can look for potential issues, you can answer detailed questions about the methods, and so on. So if you remember, I changed PC2 to actually be PC3. So you can read the code manually and find that, or you can actually ask our AI about some of the potential issues. So that specific issue actually wasn't picked up by AI, doesn't get it right 100% of the time, but you can get quite a bit of detail just because we have this full context of the code as well as the image itself. Um, if you're interested about what changed between revisions, say your AUC jumps from 89 to 90 and your leadership team is asking, it's like, hey, what did we do to improve that AUC? You can actually run a diff between different figure revisions in our portal. So let's compare this revision to this one. Well, our package has changed a little bit, but then the active document, see, here's what we changed. So you get this full kind of traceability into the exact changes made between revisions of a figure. So let's go back into Positron because I'm excited to show you a few more things. So one, of course, you want to calculate your PCA loadings. Another way to publish a plot is just to give a plotting expression to our publish function. And we support most common R plotting libraries. So if you use complex heat map, that works. If you use base graphics, that works. So this doesn't have to be just ggplot, but let's run this. Again, you get a QR code and full reproducibility. Volcano plots, again, a more sophisticated ggplot expression, but we fully capture it. We generate that QR code for you. But now what I'm excited to show you is actually our interactive feature where we can create what we call a clean room and make that figure 100% reproducible and interactive for you in the browser. So let's generate our UMAP embedding. This is what it looks like. But now we want to run some clustering on this embedding space and see if it correlates with what we saw with PCA. So the way we make this figure interactive is through a function we call reproducible. And what this does is it captures the exact inputs that your analysis needs. That includes data as well as other parameters. And then it executes that function in that clean room. So because the inputs and the packages are fully defined here, like you ensure that whatever code runs here is reproducible down the road. So let's run this and I'll show you what it looks like. So one, now you notice the QR code here gets a green shield. And what that means is that this is a clean room figure. So now if you navigate to that link, We're going to load the interactive environment for you, and now these actually become dynamic sliders. So the figure updates in real time. And in fact, you can directly tweak the code from that clean room that we use to generate this figure. Um, so most of the time, any requests for changes from your collaborators are pretty simple. For example, if they want just a title change, very simple, go into Figure Studio, change the title, rerun, and you have a new figure with a new title. Um, you can actually make this self-service if you get a lot of requests from your collaborators for figure tweaks. They can actually edit the figure directly with AI. Um, so for example, can you change, and obviously this is a simple example, but you can make this pretty sophisticated. You can ask it to change your axes. You can ask it to break it up into panels and so on. So if you have a reasonably sophisticated collaborator and you share a figure with them, they're interested in a follow-up, a lot of the times they should be able to just use the figure assistant to rerun the code and tweak the code for them in the way that they want. Um, so let me jump back to positron so I can show you the other analyses. Um, I think this whole concept of clean rooms is particularly powerful in biotech, where, as you know, notebooks are usually pretty messy. So being able to carve out those like reproducible capsules within the notebook that you want to ensure you can always rerun later, I think it's a pretty useful idea. So to demonstrate this even further, we're going to do some survival analysis. So here I'm looking at a list of proliferation genes that are relevant in lung cancer. We're going to calculate the mean expression of those proliferation genes for our TCGA samples, and we're going to see if they stratify survival. So first, we're going to generate this clean survival data frame. And now we're going to wrap the plotting in our reproducible function. So we define the cohort, gender, smoking stage, plus the actual data. And then everything in here runs within the clean room. So let's run this. So we have our figure, we have our shield. Now, if you open this, this usually takes a few seconds. It depends on how many extra non-standard packages you're included. But now this is loaded and this becomes fully interactive. So this is showing LUAD if you're interested in recalculating this on the fly for LUSC. You change it, and now we see it in LUSC. No significant difference in survival in LUSC. So you can tweak it. Um, if you find something that you then want to reshare with your stakeholders, you can actually republish this from within this interface, and you'll get a new QR code with those specific settings and filters that you put in that are baked in. So yeah, let me pause there with the R analysis, and I'm going to show you how this all translates into Python. Um, so let's open our Jupyter Lab. So now you get a follow-up request, or maybe your teammate gets a follow-up request. Like your teammate did this analysis in R, your management thought it was interesting, so now you want to do some machine learning classification in Python. We have full feature parity between the two, Python and R. GoFigr is a IPython extension that you load with this load extension magic. But that's really all you need to do, right? So this is our workspace, this is our analysis, and GoFigr is active. Let's load the packages that we depend on. let's load the TCGA data. The same kind of file sync that I showed in R is also available in Python. Here we just provide droplet replacements for the pandas methods. So instead of PD, you do GF. And then these become fully synced with our online service. There we go. So now if you click here, like this is the Parquet input file that we're going to use in this analysis. So in Jupyter actually has a very nice interface for automatically capturing graphical outputs. So in Jupyter, this is all automatic. If you generate a plot with Matplotlib or Seaborn or Plan9 or whatnot, we will automatically capture it for you with no extra calls. So here we're going to fit a lasso logistic regression or on LUSC versus LUAD and plot the differences. Notice that there are no calls to GoFigr anywhere. So you run this, this is our plot, and this is our watermark with the QR code. And this is going to look very similar to what you get in R. You get the image, obviously. You get the image in different formats. Like if you're submitting this for publication, you might want an EPS, for example. You get the AI-generated description. You can ask questions about this figure based on the image and the code. You get the link to the notebook. You get the Jupyter cell, IPython history. Like even if you didn't save that notebook before running the code, like we do capture the IPython history. We capture the assets used in this analysis. We capture your package versions and get information and other basic metadata. So now going back to our notebook, here I want to show you the reproducible decorator in Python. So in Python, the reproducible cleanroom decorator is a decorator that you wrap your function with, but it looks and feels very similar to R. So this function defines its inputs. We capture those inputs. We execute them in a cleanroom environment. So this becomes fully reproducible, even years down the road in that sense. So let's run this. In Jupyter, you get some interactivity in the Jupyter interface yourself. So if you want to subset this here, like this is fully supported. But now if you view it on GoFigr, you get the exact same kind of interactivity that you did with R. So we're going to load the clean environment for you. These are the inputs, just our true labels and the predicted labels. And when you tweak the dropdowns, the figure automatically regenerates. You can view and edit the code directly in GoFigr Studio. If you're really just making a small change or just exploratory stuff, you can ask our AI assistant to do it for you. For example, I don't want to see this as an ROC curve. I want to see this as actual points in a box plot. After a few seconds, this will come back with a code change, and there we go. Oh, it's not an actual warning. It's not an actual error. It's a warning, but the AI agent fixed it, and now we have our RC curve shown as a box plot, which in some setting might actually give you more information. So now if you want to share this, click publish. This will get a QR code and you can share it directly. So finally, the final figure I want to generate here is the correlation between the differential expression log two-fold change and the machine learning coefficient from logistic regression. Because logistic regression is a linear model, like these are fairly well correlated. But this gives me another figure in my analysis. So now if I go back to the GoFigure portal, if I go into my analyses, this is what we've been working on. These are the figures from both R and Python captured in a single unified interface. Like you can click through, you can see the data, you can see the exact version and iterations that were produced. But now the final feature I want to show you is our story feature, where you've done all this work in a notebook to generate figures. Now you want to put it together into a coherent presentation. That's something you can absolutely do with our stories feature. So now let's go back to our analysis. Let's click Create Story. I'm going to select the exact features that I want to include. Maybe let's only include the ROC curve and not this one. Yeah. So I'm happy with this. I'm going to click Create Story. And this can take anywhere between 5 to 20 minutes, depending on the number of figures that you have. So I'm just going to show you what that looks like once it finishes. So once that finishes, you're going to get something like this. It's a fully drafted PowerPoint presentation that includes an introduction, goals, data, methods, and the exact figures with detailed descriptions. This is based on the analysis of, again, not just the figure image, but also the code as well as the data behind them. So for my very informal evaluations, this is usually pretty accurate. So here are our figures. This is fully interactive. You can ask questions about each figure. You can also view the code and the data directly from this interface. So if you're going over your results with a collaborator, you can get a lot of information directly here without leaving the GoFigure interface. Um, so yeah, these are all our figures complete in a soup to nuts PowerPoint presentation, including the conclusions as well as future work. In the name of transparency, every single figure that you put in a GoFigure story, you can actually click on every single claim that is being made about this figure, and get specific evidence for that claim based on the code and the data. So yeah, let me pause there, and maybe we can leave a few minutes for Q&A. If you guys have any questions, please feel free to send them in the chat, and I'll be happy to answer. All right, let's give you guys one more minute. Okay. All right, so one question is about the libraries that we support in Python. And we essentially support the most popular ones. So we support Matplotlib, we support Seaborn, we support Plan9, and we support Plotly. Adding new backends is generally pretty straightforward for us. So if there's a plotting library that you really like and love, let us know and we'll be happy to implement the support for you. But Yeah, sounds like that was the only question. So maybe let me leave you guys with our. Oh, there's another question, sorry. Do you have to add the QR codes to the figures? Is a link possible? You can actually customize these. Like, go if you don't like QR codes, you think they're too much, you can either show just a link, um, or you can choose to skip the watermarks altogether. And that actually brings up an important point, which is our search functionality. Um, so even if this ends up in a PowerPoint presentation where somebody crops out the link or the QR code, you can always find the figures with search. So we fully index the source code, the labels, and the labels within each image. So you can actually search this by text, right? So find me all the figures with the word random in them in this workspace, and it happens to be just ROC curves. Um, so click on this and you get the figure. Um, we also support image search. So if you go under search, image search, there we go. Like here's our ROC curve. Um, we actually calculate a high dimensional embedding for every image on the back end. So this works pretty well in practice. And even if you don't find the exact revision as the top hit, it will usually be in the top five. So narrowing this down even without a watermark through direct search is very much a possibility and something that we fully support. Um, awesome. So with that, I'm going to leave you guys with our links and free resources. Um, if you would like to redo the analysis and try this yourself, like everything that I showed you today is available on our GitHub. Um, if you want to sign up for an account, it's free. Um, send me a note and I'll give you a free plan upgrade if you think this is something that, looks interesting to you. And finally, our documentation is available at docs.gofigure.io. Um, so I'll end there. I just wanted to say, thank you for listening in. I'm hoping to make this a bi-weekly series. Um, and yeah, stay tuned for updates. The next time we do this, probably in another 2 weeks, I will let you know. And yeah, enjoy the rest of your day. Thank you so much.